Hello and welcome to the vodcast about Year 8 physics and in particular energy. Here is a full picture of the mind map before we zoom on in. The first topic is the different forms of energy. The definition of energy is energy has the capacity to do work or produce change. And there are two basic types. There is kinetic energy and potential energy. Kinetic energy is the energy of motion and potential energy is stored energy. Within kinetic energy, we have thermal energy, light energy, sound energy, electrical energy, and radiant energy. And within potential energy, we've got gravitational potential energy, elastic potential energy, nuclear potential energy, and chemical potential energy. All right, first we're going to look at kinetic energy, which is the energy of movement. And the equation to work out kinetic energy is Ke equals a half mv squared. The units are joules, and the symbol is J. M is mass in kilograms, V is velocity in meters per second. So we're thinking about a car. Speed and velocity are pretty much the same thing in Year 8. There's how fast it is travelling, and in this case it's travelling forwards. The mass of the car is M, that's how heavy it is. And remember the equation is a half mv squared. So if we have a car that has a mass of 1,000 kilograms and it's moving at 20 meters per second, the kinetic energy is calculated by using the equation Ke equals a half mv squared. So we put the values into the equation. A half times 1,000 kilograms times 20 squared equals 200,000 joules or 200,000 J. This means the car has 200,000 joules of energy. Next, we're going to talk about the conservation of energy, which is that the energy in a system is constant. The energy cannot be created nor destroyed, only transformed or transferred. In a closed system, this is true, but in the real world, energy is lost due to friction. The energy lost is normally converted into heat, sound, and light. With the pendulum picture, we see that as we pull the pendulum up to one side, it has the most potential energy, and then as we let it go, when it gets down to the bottom, it has the most kinetic energy, and it won't have lost any energy due to the transformation of the energy, and theoretically, no loss of energy. So next we're looking at energy transfers. Energy can be transferred from one form to another, and in an ideal world, the total energy will stay the same. So first of all, there is mechanical transfer. When a hammer hits a nail, it transfers its energy into the nail. Electrical transfer is the transfer of energy from a battery through the wires to a light. Thermal energy is when heat moves from a hotter object to a colder one. Radiant transfer is the use of electromagnetic waves to transfer their energy into food inside a microwave. Chemical transfer is the transfer of chemical energy during chemical reactions. And nuclear transfer is the use of fusion and fission to transfer their energy into heat and light. Whenever we have an object falling, it converts the gravitational potential energy into kinetic energy. And we're going to discuss a trolley on a roller coaster. The trolley is 400 kilograms in mass, and it's 100 meters off the ground. So at point A, it only has gravitational potential energy. And to work out that GPE, the equation is mgh. So if we put in the values, GPE equals 400 kilograms times 9.8 meters per second for gravity times 100 meters, which is the height, and it equals 392,000 joules. As the cart starts to move, the energy in the gravitational potential energy is transferred into kinetic energy. At point B, which is only 50 meters high, half of the GPE has been converted into kinetic energy. So we still have half the energy as gravitational potential energy at 196,000 joules, and the other half has been converted into kinetic energy, which again is 196,000 joules. And as the cart goes away from B and falls down the last bit of the hill to C, all of the GPE has been converted into Ke. So the kinetic energy is 392,000 joules. Now to work out the velocity of the cart at C, we need to transpose the equation for kinetic energy. So remember Ke equals a half mv squared. We need to isolate V. So if we go through the steps, because it was divided by 2, it's now times by 2. So it's 2Ke equals mv squared. Then we need to move the mass, so it becomes V squared is 2Ke on m. And now we need to get rid of the squaring, so V equals the square root of 2Ke on m. And if we work through this equation, we find that V is 44 meters per second. Next is chemical energy. Chemical energy is the energy stored within chemical bonds. Energy is released when bonds are broken, and energy is stored when bonds are formed. And there are two types of chemical reaction: exothermic, which releases energy, and endothermic, that absorbs energy. In an exothermic reaction, the reactants have more energy than the products. And an example of this is cellular respiration. And in endothermic, the reactants have less energy than the products. An example of this is photosynthesis. Batteries can transform chemical energy into electrical energy. Electrons move from the anode to the cathode. The device or the toy or the light is the electrical circuit, and this is called an electrochemical reaction. Next is light energy. Visible light is only one part of the electromagnetic spectrum. Therefore, light is a type of radiant energy. Visible light is only one of the forms of energy released by the sun. Visible light is remembered as Roy G. Biv. The longer wavelength is red, and the shortest wavelength there is violet. So Roy G. Biv stands for red, orange, yellow, green, blue, indigo, and violet. To calculate the energy of light, or photons, the equation is E equals hf, where E is the energy of the photon, h is Planck's constant, which is 6.626 times 10 to the negative 35, and f is the frequency of the light, but I doubt whether you're going to need to calculate this in year 8. Next is radiant energy, of which visible light was only one component. Radiant energy is the energy in electromagnetic waves. Electromagnetic waves are transverse waves. That means the electric and magnetic waves are at right angles to one another. And there are two types of electromagnetic wave: non-ionizing and ionizing. Non-ionizing can't remove electrons. It can only heat things up. And these are radio waves, microwaves, and infrared waves. Ionizing radiation can remove electrons. By removing electrons, it forms ions. Hence, it's ionizing. And this is ultraviolet light, X-rays, and gamma rays. Here I have a little acrostic to remember the waves in order. Rich men in Venice undo extra gondolas. So that's radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Next we have sound energy. Sound is a mechanical wave, and that means it needs matter to travel. Sound is also longitudinal because the energy moves in the same direction as the wave. In sound energy, vibrations are passed between particles as they collide. Compressions are areas of high pressure, and rarefactions are areas of low pressure. Within the wave, we can see that we've got a wavelength, which is one complete wave, or from crest to crest, or trough to trough. Volume is the amplitude, so the height of half the entire wave, and the frequency also determines pitch. Then we have thermal energy. Thermal energy is a type of kinetic energy. As the particles heat up, they vibrate more. Thermal energy is the total kinetic energy. Heat travels from hot to cold by vibrations. And there are three types of movement for thermal energy. Conduction energy is the heat movement through solids. Convection is the heat movement through fluids, which are liquids and gases. And radiation is the heat movement through a vacuum, air, or space. And last of all, we have nuclear energy. Nuclear energy is the store of energy inside the nucleus of an atom. And again, it's potential energy. We have fission, which is the splitting of a nucleus, and fusion, which is the combining of nuclei. Both of these processes release energy. To calculate the nuclear energy, we have the very famous equation E equals mc squared. E is the energy released in joules, m is the change in mass in kilograms, and c is the speed of light, which is 3 times 10 to the 8 meters per second. And again, I don't think you'd ever have to calculate E equals mc squared in year 8. Thank you for listening. I hope you've learned something. Don't forget to like and subscribe, and I'll catch you later. Bye now.